Hi, I'm Christopher Tapia Carmen, and this is my Physics 2212 charge tape revisited. The content of this lab include the purpose, procedures, physics behind the lab, code, error, and some questions that may arise. The purpose, we're trying to analyze how charges interact in the real world, but with a more effective model compared to Lab 1. In Lab 1, we took everything as a point charge and took the middle of the tape as our R, and that created more error as opposed to now we're going to take multiple different charges in a rod-like formation and see how the electric field and force differ from the previous one. We're trying to verify that Newton and Coulomb's laws are correct and then find the charge and electric force from tape B to tape A. Procedure, we need tape, meter stick, objects to support, a laptop for coding, and some sort of camera to record the experiment. The procedure is the same as Lab 1. You're just getting a bottom tape, ripping it off, and a top tape, and ripping the top one off. And then you find out that when you rip it, it negatively charges the tape. Physics behind this lab are Coulomb's law and then Newton's second law of motion. And in Lab 1, we figured that this is how we found our charge of the tape. However, we're going to see further into the lab how it differs in Lab 2. This is our actual experiment. You can see that they repel, and then this is further showing the repelling between two negatively charged tapes. Boom, boom. All right, so our Lab 1 results, we found that the tape had a charge of 1.6 times 10 to the negative 9th coulombs. And then the electric force on tape B. Tape B was the top tape, and tape A was the bottom tape, was around 3.9 times 10 to the negative 6 newtons. So this is how Lab 2 most significantly differs from Lab 1, and it's the code. So for a mass, these are just constants that we found, like this was our experiment. And then for the function here, the definition E field, this just applies the Coulomb's law, and then and then for line charge, it just creates like a uniform rod, basically, of how many ever atoms are making the piece of tape, and we said that N is 35 in our case. All right, so this for loop basically calculates each of the E fields of each of those atoms in the previous, like our N. So if N was like 10, it'd go through 10 of them and calculate and then display their arrows and the force, the E field that it causes to tape B. And that's pretty much it. It just creates the arrows and scales them as well. These were our results. These are just all the E fields shooting up, and then our electric force was 1.9 times 10 to the negative 3, and our force, and that was our force. All right, error. Some error may be air resistance, and we assume that the tape's charges were evenly distributed, which is most likely not true. Questions, what if? What if you had modeled each of your tapes as a single point charge like in the previous lab? Compared the estimated values. So I put the estimated values here. In the first lab, it was around 10 to the negative 6. I messed up here. So it actually differs by a constant of like 1,000, which is a lot. It's too much. So we eliminated some error here as well. Why did these estimates differ? These estimates differ because since R is so small and it's squared, and it's different between each particle, they're not all at the center. It just creates a really large difference in electric field. Thanks for watching.